Hello, everyone. I think everyone is doing very fine. So, fine. So, finally, I am here. I chipped in some time from my usual work for you people, and I hope it will help you guys. At least, this is what I expect. I don't know what will happen, but at least we should begin by expecting something good. So, today, what we will be talking about is a new, and I share what has been done in your syllabus. So this is a part of your syllabus, and there has been a new portion added, which is coordinate measuring machine. And today I will try to talk about this. I will not definitely be able to finish it in one class, but yes, at least I will try to start it now. So fine. So we know what is today's agenda. For sake of stating it, I will be writing it. So our today's agenda is CMM, which stands for coordinate measuring machines. Now, to understand this topic entirely, I have thought of dividing it into five parts, and one by one we will take it up. So first part is that what is a CMM? What is a CMM? Why is it used? What is it? What are its advantages over the like the usual process what we were following? What is the principle of it? Principle on which it is based. Then for this there are three small terms I will talk about, which are nominal shape, actual shape, and substitute shape. Yeah, don't try to figure me out by this. This AK is for AK-47, so it is totally useless. Okay, so second thing will be some mathematics. The mathematics which is used in the CMM functioning. We will talk about them in detail. And personally, if I feel that if GATE will ask any question numerical based, then it has to be from this area. Otherwise, from where will they ask? And if it is conceptual based, MSQ type, then also we will cover the suitable theory. Then this is the second number. Then the third thing will be uh, different components, different types of CMM, then components of CMM, structure, etc. etc. There are so many things I will talk about in this area. Then a very important portion, which is sources of inaccuracy in CMM. Now, this sources of inaccuracy, of course, if you will understand, then the next question will be how to test them. And once if you are testing it, then how to eliminate them. Means a very simple thing. If you know the problem, then why you are not solving it? As simple as that. First, you should know what are different sources. Like you should always try to understand what are the sources, the reason behind you not scoring good. Once you know them, then next step will be how to test them. Like how you will understand that you are scoring less because of so and so reason. So there will be some tests, like test series, and then how to eliminate them. Keep practicing, keep improving yourself every day, and eventually you will succeed. That as simple as that. Once this is done, then the final thing we will talk about evolution. Evolution of CMM means what next? What next CMM? Like if is CMM the most desired thing, or is this the final solution what we have? So if not, then what next? What next? What next? As simple as that. What after CMM? So we'll talk about them. Today I will try at least to finish first portion, and then I will carry on in subsequent lectures the other portions to it. So let's talk the first question, the first pertinent question or the first pertinent thing. What is a CMM? So CMM stands for Coordinate Measuring Machine. It's even written in the syllabus. So what? Which coordinate does it measure? Like, what do you understand by coordinates? And where is it measuring? Like, what you will do with these coordinates? So actually, these are the coordinates on the job. On the job. What is CMM? And what is CMM is a coordinate measuring machine. It measures coordinate. These coordinates are on the job. And what eventually you get is that these coordinates, if infinite number of coordinates you join, then you get surfaces. Not directly. In fact, infinite coordinates are joined, then you get line. When many line are joined, then you get surfaces. When infinite surfaces are joined, then you get body. So, in fact, a CMM is a machine which will give you the final geometry of the object. This is the object. You use CMM to get the geometry of this. This geometry will be 3D, not 2D. Fine. So, how is it done? Next question. How is it done? So, let me see. If I have a picture of CMM, I will put it here. Then it will be easy for me to explain from there. Otherwise, it might get. Yes, it's there. Now, see, this is a bridge type CMM. Now, don't worry about this bridge type and all because now we will talk about this in detail in structure. Now, see, this is the job. This is the CMM machine, okay, on some stand and all. This thing is called probe. So this probe is touching the job at different locations, and then it is detecting a coordinate. Suppose this point is contacted, then this coordinate is sent to a computer. This computer will be kept next to the, of course, wired to it. So this computer will take the points. Similarly, all the coordinate points will be taken into this computer, and then by some software, you will get a approximated 3D model of this. And then this 3D model is compared to the job, and then the inaccuracies are estimated. Now, of course, I will be telling, like, it's not so simple as I have said, but yes, it's not so difficult also. Now, to understand this, there are few things what you should know. Like few terms. One is actual shape. Second one is nominal shape. And third one is substitute shape. So this actual shape means shape what you have obtained. And yes, I will not be telling this again and again, but whenever I say shape what you obtain of job, fine. Don't start singing the song Shape of You. So second one is nominal shape. This is what you expected. Now, when I say you have to be feel like you should get very happy. Here, you means the designer. I'm calling the designer because you have some expectations. You will ask me that, sir, I want a like this is the rim of a car. So you will say, sir, I want a rim of car which is of so and so material or so and so shape. So I will be getting it machined in some CNC and then I will bring it to you. So what you were expecting that it should be a black color of dia 300 mm and so and so. So this is your desire, your expectations, and this is called the nominal shape. How you will be telling me this? This you will be like uh, like how an engineer will correspond to each other. That is by CAD models. So some CAD model you will give me some drawings, you will give me some engineering drawing that I want so and so model of a job. Then I will get it done by some CNC. I will give it to some, let's make my life easy. I will use some CNC. I will get something manufactured, and what I will get is be the actual shape. Now to estimate this, actual shape, I will use CMM, this animal, CMM animal. So this animal, what it will do, it will take many points all over the job. It will send to computer. Computer will make a numerically constructed 3D model of this. And this constructed model, numerically constructed model by CMM will be called a substitute shape. So we have three shape understanding. Now you know what are these things. Okay. Again, just for sake of like revision type of thing, I should say, or for more better understanding, let me show you one more diagram. So yes, this is the thing. Yeah. So what is this? This is your actual shape. This is actual shape means obtained shape. Obtained after manufacturing. This manufacturing can be by milling, drilling, let us say CNC completely. These coordinate points are taken by CM. These coordinate points are taken by CMM, this polka dot type of thing. Then a numerically constructed surfaces are made by the computer. This is made by CMM. This things like these points are made attached to the surface and then it is made by substitute shapes. This is your numerically constructed. And now this numerically constructed shape is compared to the nominal shape. This is the comparison. And this comparison is done with a CAD model. And this comparison results are called the test results. Comparison results are the test result. These test results are sent to designer. Now designer has a responsibility to take care. He will see whether these deviations are okay for him or not. If it is okay, well and good, he will accept the job, he will fix and he will make whatever he want to make. In above case it was car, he will put that in car. If design is not happy, then he will be giving some corrective actions like I'm not happy with its color, make it black. I'm not happy with its dia, try to increase it. Uh, Corrective actions. And even after corrective actions, again this entire process is done. Still, if the designer is not happy, he will throw it, scrap. Fine. So every scrap is having, like, before a machine or a component is thrown as a scrap, there is so much of uh, like value addition is done. Suppose like if this cycle is going on for 4 times, you just understand the amount of time it has been spent on one job and amount of labor what has been put, amount of value what was added to it. So it is not always easy to scrap everything up. So it's a very big responsibility. Like if this manufacturing process is having some problem, then a very core and root cause analysis is done, and then like the life of engineer in those areas, those who are doing it, is very helpful. So fine. So now you know how it is done. What is the use of CMM? Now earlier how it was done, like what before CMM? So before CMM it was done manually. So manually it was done. So you can very well say that what is the advantage of CMM, sir? It is very quick because it is not manual. Accuracy will be higher, errors will be less. So these are some book type of examples what you can give. But if an interview, if someone is asking you, you better not say all these things. Sir, it is very cheap, mega hai sir, sasta hai sir. All those things if you will say, they will laugh on you, and it's not always good. So some points I have mentioned now, but these are also has to be taken with a pinch of salt. I will tell you what salt you have to use. Now, manual time consuming alignment of the test piece. Oh, now in conventional metrology, there is a very big problem, that is alignment trouble. What is this alignment? Again, I will be talking about this in detail after some time. In coordinate measurement, alignment of test bed not necessary. Now, this is the what I took from a book. And now see, this statement itself is wrong. Alignment of test piece is not necessary is wrong. Actually, alignment has to be done, but it is easier to do. Never say it is not necessary. It is necessary. What is the meaning of alignment? We'll talk. But yes, here it was done, it was very time consuming. Here it is easier to do, not so time consuming. Now, when conventional was done, then one person will use one, suppose he has to measure one dimension, he will use one, uh, suppose 1L caliper, and then he will do 1 point testing only at a time. And then he has to do so many measurements on the entire body of the job, and finally he will be done. So it is time consuming and single purpose and multi-point measuring instrument, making it hard to adapt to changing measuring tasks. Of course, suppose there is this size of 1 year caliper with you. Next time a bigger job is coming, so bigger this thing has to be needed, right? Bigger 1 year caliper is needed. So tools are also a problem. This, of course, measuring test by software, fine, no issues. Now comparison of measurement with material gauge blocks. Okay. Now this point is something you have to understand. Now suppose you are measuring few dimensions on a of a job manually, and here you are measuring something with CMM. With what will you compare? Like to understand the difference between the expected and what you have obtained, with what you will compare. Here also you will compare with CAD model. Here what also you will compare with CAD model. So now see, here CMM is computer or machine, CAD model is by computer, machine. So here computer versus computer. So of course error will be less. Here it's man versus system. So error will be high. So this is not good. Now it's separate determination of size, form, location, and orientation of different machines. Determination of size, form, location, orientation of one setup using one reference system. Okay, this reference systems and all we will again talk in detail. Nothing to worry about. Next question is, now we know that we have to somehow create substitute shape. Once this substitute shape is constructed, you can compare it with something. CAD model. I will write compare. So our aim is to make this now. Make this. Now to make this, there are few terms which we should know. And just knowing those terms will not help us. We will have to know some mathematics also. Fine. So all the shapes are a combination of or a summation of few standard shapes. Example, if I make a cube, then cube is made up of 6 planes, 12 edges. Fine. 4, 4, 8. 8 uh, vertex. So these are points, these are lines, these are planes. So you can break down this cube into so many things. So similarly, all shapes, whether that be substitute, nominal or anything, are again broken down into standard shapes. So you should know what are those standard shapes. Fine. So these things, standard shapes or geometry. We also call standard shapes or geometry. Now, these geometry, to make any, construct any geometry, we need some minimum points. Example, suppose there is a line, 2D line. How many information do you need to construct this? How many info? How many info is needed? Answer is 2. 2 info. These 2 info can be of different types. This can be either you give me 2 points, or you give me 1 point, 1 slope, or you give me slope and intercept. Actually, this and this are same, but still. So any 2 info will fix this line. So what we will do, we will not talk about these two things. And as it is a coordinate measuring device, it can only measure coordinates. So we will stick to this, that 2 points are needed to plot any line. If I give you 2 points, this will be fixed. Suppose only 1 point is given, you can make infinite lines with this. So if 2 points are given, there is only one unique line which is possible, which can be constructed. This is very basic class 11 knowledge, what people already know. So similarly, for all other geometry also, there are some minimum number of points. So for all geometrical shapes, some minimum number of points are needed. To construct it mathematically. But these are for ideal surfaces. For ideal surfaces. Means suppose there is a plane. So to fix this plane, or to have all the information about this plane, you need only 3 informations. But when in actuality this plane is machined, it might not be plane. It will have some deviation. It will look something like this. Okay. Means this will be plane, but there will be some another deviations. So these minimum number of points are not sufficient. As these are not very ideal shape, again I repeat, suppose this line is straight, then only 2 points are okay. But what if this line is, everything is fine, little bit screwed and this here. So this skewness cannot be dealt by only 2 points. You need some additional points also. So some additional points to cater the variation in shapes are taken. So now another question is, how many points? How many points? Now, a common question answer will be infinite points. To know the orientation of a curved surface, it's always better to take infinite points there. You will get a perfect shape. But that is not practical because after a couple number of points, the accuracy gets saturated, and that is called accuracy independence. Suppose you are very hungry, and if I ask you, you are very hungry, how much you can eat? You will say, I can eat too much, sir. But that is not quantification. Like after 10 parathas, you might get saturated. Like, okay, fine, you can eat 11 also, but after 10, you are okay. After 10 parathas, fine, man, you will give me some two. Fine, I can eat it, but I don't need it actually. I was happy with 10 also. I was happy with 8 also. So we don't go for so many infinite points. We go, but like we have done some experiments and we have reached optimum points, number of points, and these are called metrological minimum number of points. Now for line it is 2, for plane it is 3, but these are mathematical things. For like for these things there is a different set, and I will tell you the chart. Here is the chart. So see, yeah, this is what I was talking about. See, these are the mathematical minimum number of things. Like for line it is 2 for mathematical, but for metrological minimum number of points I will always in future call it at MMNP because I am very lazy. I cannot write so much. Kindly excuse me for that. So for circle, you need 3 mathematical points, but metrologically minimum numbers are 4. For plane, we take 4. For sphere is 4 and 6. Cylinder is 5 and 8. Cone is 6 and 12. So how to remember this, and is it necessary? Uh, See, you see this chart couple of times, you will remember it. It's not a problem. But you can also remember it the way I am telling you. See, actually, we classify into 2 classes. First classes is curve which can be touched. Example, plane, cylinder, sphere, etc. And second class is, this is the first class. Two classes right here, small. And second class is which cannot be touched. Example, point and line. Now you will say, sir, what do you mean by line? Line means edge and point means vertex. Now next question will be, sir, why you cannot touch it? It's ridiculous. Now I can, you give me a cube, I will show you how to touch the edges and point. Yes, you can touch it, no issues. But actually that's a machine. And machine is doing that with a probe. So what is the trouble, I will tell you. See, probe is something like this, a sphere. And this is your jaw. If there will be a contact at this point by between the sphere and the workpiece, here the contact stress will be very high. What will be the area over here? Area of contact. It is almost 0. So even if the force is very small, stress will be force by area tending to infinity. So such cases are called Gaussian stress. It is not in your syllabus, don't worry. But this is the reason why higher pairs in Tom. Tom means not Tom, Dick, and Harry. This is theory of machine, where you say it is having some line contact or point contact are wearing off very easily. The wear and tear in higher pairs are higher comparative to the lower pair. So here you see it is a type of higher pair combination only. Force, even if it is very less, the area of contact is tending to zero, which is very small. So the stress will be tending to infinity. And such cases, you are not like this is not in your syllabus right now, so you don't need to worry about this. But yes, this are called Hertzian stress, which becomes very high. So what we do, we never touch a probe to a vertex or an edge of an object. I hope you understand now. Right? So because of this logic only, we say there are two classifications what we do. Uh, like geometry which can be touched, geometry which cannot be touched. Okay. Now, how to do this? Yes. Now, one more thing you have to know that which cannot be touched. These are formed by Boolean or above curves. Boolean means a point is formed by combination of three planes. A vertex, sorry, this is point. A line is formed by two planes. Like you take two planes and like just intersect them. You will get a line. Okay. So this plane, plane 1, and this plane 2, their Boolean is this line. Similarly, if there is one more plane over here, if there is one more plane, then this will become the vertex. It is Boolean of three planes, 1, 2, 3. So this is one thing. So now another question is, where are these things used? Where are these things used? Okay. So suppose you have a job. A job. Let me show you a picture. If I am having, then I'll show you. Suppose this is the picture. Yeah, I have this. Now in this question, you need to find the dia of bore, dia of bore. This is the bore, okay? And dia of bore and location. Location of bore. And this has to be done by CM. So how it will be done? Now you see very carefully that if our probe is touching at this point, like this, do you think it can tell you the radius of this bore or the dia of this bore? No. Why? Because here it will be an ellipse. This probe will touch continuously many points and then it will tell me an ellipse. Similar problem is here. If my bore is touching here, then also it will be an ellipse. So very carefully we have to take care so that the bore, like our probe, touches this point at this point perpendicularly somehow, so that it will give me at this plane a circle. Fine. So first thing is that we have to be very careful about how much is the contact and at which point the contact is happening. Fine. So dia or bore is obtained by correct location, correct combination of one cylinder with cylinder, this cylinder, the type of cylinder only, right? Plus plane. Which plane? This plane. So you needed a bore dia of a bore. So it was a type of circle. So this thing was obtained by a combination of these two things. Whereas for location of this bore is the combination of axis of bore and one plane. So see, this is the axis of bore and this is one plane. So this is the location of, this will be center line of bore. You need know the dia, so you can drill it up. So this entire bore can be constructed with it. So with this, I will be closing today's lecture and let's recap everything up. Huh? In the next, okay. So we started from here. So syllabus, agenda, these are the 4 points what we will be talking up in next classes. This was the introduction what we did. Little bit of mathematics. There is too much thing in this. Next class we will come to strategies of this, how to construct, what to construct. Then too many things are there. Today I have just completed this number one part and how this and these mathematics is related. Just I have talked the very basic of it. Then this is the CMM. We will go into structure types in future later. But for now, these are the three shapes what we understood. Again, we understood the same thing, the comparison between the conventional metrology and the coordinate metrology. Then what we did, we talked about degree of freedom of geometry, degree of freedom. We discussed about this degree of freedom of geometric curves and how many mathematical minimum number of things are needed. This is also called, I forgot to mention this, sorry. This is called degree of freedom of this curve, this thing. The minimum number of mathematical terms. These are called degree of freedom of curve. So if someone is asking what is degree of freedom of a sphere, then you can tell him 4. For circle, it's 3. For plane, it's 3. For cone, it's 6. So that is one thing. Then we talked about why your probe cannot touch edges and vertex because of this Gaussian stress, which will be quite less, which will be quite high, and we will try not to do that. And a strategy how your probe should touch so correct values are obtained. Fine. Thank you. You guys kindly subscribe, like, press the bell icon. These are the things what people say, what I have seen over YouTube. But you people take care of this. Yes, I would like to mention one more thing what I have observed that uh fine, this is a little bit out of topic, but still. See, I have observed this thing. This is the energy curve and this is the time curve. When someone is starting something, then his energy is at peak. And as the time passes, it dips down. Energy, this is the area. Area is your content. So when you are starting, your energy will be high. Content, of course, it will be less. Suppose if this is the time one day, content will be less, man, because you haven't got the suitable time. But with time, in between, your content level will rise, and with time, it will deplete. So, how to increase this area? That should be the aim. So, this can be increased by suitable motivations, and are those motivations are actually these things. These are the motivation curve. So these things go up by support of people. support of people as in by like, share, subscribe, anything. So as these go up, the content will be increased. So this is in your hand. Inside this is under my hand. Time is under no one control. Energy, I don't know. I will try my best. But this can go up. Whether this is low or high, that doesn't matter too much. This cup should shift up. Because if it is not going up, this area will be less, content will be less, and you will be on the lagging side. So I hope you understand. Okay, see you guys. Bye bye. So next time I will try to put something of next portions and then we will see what to be done. Thank you guys. See you.